Hello everyone, and thank you very much for watching this live event, lesson 5 from the Spring Reactive playlist, and we are going to discuss today about the publisher more. We continue the discussion from the previous lesson when we started to discuss about the subscription, the subscriber, and the publishers, Flux and Mono. I still have a lot of things to tell you about all this, and I have a lot of questions that I got during the previous week, so we have a lot of things to do today. If you're watching the event live, don't forget that you have a live chat there, so you can ask me questions in the live chat directly. If you are watching the event recorded, you can still ask questions in the comment section, or find me, of course, on LinkedIn or Twitter. And let's start with reminding you which were the contracts that we are discussing about. So I prepared here my Inkscape to draw a very simple diagram again, and by that tell you again that we are discussing about a publisher. And remember that the two publisher implementations that we're mostly using are Flux and Mono. Where Flux is, you can imagine it as a pipe with multiple events of zero or more events, and Mono, which is like a Flux but for only one event maximum, so Mono will have 0 or 1 events. And also one important thing you need to remember from the previous lesson is that you always need to have a subscriber. So the subscriber will be the one to consume events from the publisher. And one important thing that again we really need to remember is that between the subscriber and the publisher we have the subscription. So once we remember all this, one of the questions that I got this week from you guys, let me just screen subscription. One of the questions I got from you guys was that it's still not clear enough what is the difference between this reactive stack and the Java 8 stream API, and I wanted to try at least today make a bit more clear the difference between the two, because they are not the same thing. And then once we do that, I'm going to continue with implementing a publisher. And the reason I'm implementing a publisher is not because you will do that yourself plenty of times in applications. You will mostly be using still Flux and Mono for anything that you need. But it will make things a little bit more clear, and maybe even this way answer better the question about what's the difference between the reactive stack and, for example, Streams API, because it seems that this creates still some confusion there. So you will see that it is different. Now, to do that, of course, I need my IntelliJ and I need to start a new project. Let me call it the same way I was using to call it. So this is Spring Reactive C5 E1 for the first example, and we are using the latest version of Java. Not that it is important, and the only thing I'm adding here is the reactive web dependency. I'm creating a reactive web application, but today, again, as we did in the previous lesson, we are focusing more on Mono, Flux, publisher, subscriber, and subscription. So in the first lessons we discussed a lot of things about web apps in general. We discussed about the two ways of implementing the web applications endpoints, like through routes and using REST controller. We discussed about having event-driven consumption versus non-event-driven consumption for the endpoints. We discussed even how to connect to a database. We just very fast connected to a MySQL database using the reactive driver. and we even discussed about web clients and how to consume events from a reactive application. So how to create a proxy which becomes a client of another reactive application in a Spring app, and we still have to continue with some parts of those, but we made a good progress. But last time and also today we are going to focus more on, again, monoflux, the architecture behind the scenes, because trust me, it's really important you understand that as well. So it's one of the things that I observe with developers is that they tend not to understand properly what's behind the scenes with technologies that they use, and that's especially with more complex things like reactive or Spring Security, for example. And I want to put here in these videos, for those of you who understand the importance of knowing what's behind the scenes and understanding the architecture, the basic architecture contracts, not only in terms of how to use them, but also in terms of what's behind the scenes. I want to put all of this here. So let's say we create a controllers package for simplicity, because I'm only creating a very simple demo endpoint here. So just say demo controller, and then I'm gonna say REST controller. And you already know that you can use REST controller still. So, but in this case, I'm just going to create an endpoint to be able to call the code I'm going to prove. So it's not really an endpoint, it's just some way to call the code and show you things are working the way I'm telling you. So remember that you can create a flux, for example, a flux of integer, and the easiest way, of course, to create it, we've seen a few ways already in the previous lessons, but if you only want to enumerate some values, you can just say flux just, and then say whatever values you want to be on that flux. And then of course you can say subscribe, and you have a subscriber here, so you can use whatever subscriber you want. And in the previous lesson I've shown you how to create a custom subscriber, but at the moment I actually will use the subscribe method that gets a consumer as a parameter to simplify the things a bit for our first discussion. Our first discussion, as I stated at the beginning, is stream versus reactive. So say stream API versus reactor, what we are doing here. Okay, you know that if I'm going to simply run this code, this is a very simple endpoint, and what we'll do is that I have a publisher, and you can see that I created a subscriber here through the consumer. So I use that very simple overloading of the subscribe method that gets a consumer as a parameter, and what it creates behind the scenes is of course the subscriber. The subscriber using as main code, main implementation, the consumer that I have provided, which doesn't do a lot of things. It only prints in the console the values that are provided by the publisher. So again, what people confuse this is saying that this looks like to be the same as Streams API, isn't it? So I've started my application, and I'm going to prove that's doing what I'm telling you it's doing. So I'm starting the application, and then in a browser I will simply call localhost and nothing actually, so it's just localhost and nothing. So I'm just in the browser I just called localhost and nothing because I have no path here. So just localhost 8080, and we know that 8080 is the port that is by default configured in the NET implementation. You can even see it here in the console, and you see that indeed we get the values. Okay, so you can say, okay, can't I actually do the same thing with Streams API? So I can say stream of integer s1 is stream of, and they say 1, 2, 3, 4, 5, 6 to be the same. This is equivalent to the publisher, and then I will say S1 for each, and I will simply copy the consumer, which looks to be equivalent. So in case I'm running this and I'm going to restart the application, I'm going to run it to show you, you will basically see the same thing. And then of course it's absolutely normal that this will create a confusion, because it simply looks like absolutely the same, isn't it? I'm just using flux here instead of stream, and I'm just having a different method name here, but it looks like I still provide a consumer and I still have some kind of a subscriber. And that's because it literally and you can see it does the same thing. It literally it's very similar in terms of the architecture itself. So you will indeed still have a publisher and still have a subscription, but there are a few different things. And the first one that I mentioned also in the previous episode, but I want to make it even stronger now, is that in case of the flux, it is first always the subscriber requesting values. So if I'm going to put this again into that syntax where that we've been discussing in the previous episode, you remember that I can write this here like subscribe, and then I have a subscriber. And then what I have to do is override those 4 methods, isn't it? So it's not that easy in the end, because once you, and like in this case here, once you create a subscriber, one of the first very important things is that this subscriber needs to get and keep a subscription for itself. So I can say just public subscription, which I will assign from the method on subscribe, which if you've been attentive in the previous lesson, is the method that the publisher will call when a subscriber needs a subscription to get values from them. And we will see this today when going further we will create our custom publisher, and then it's still the subscriber always the one who will request. And remember, if the subscriber doesn't request anything, the subscriber doesn't get anything. And that's the first biggest difference between the Stream API and the reactive stack, is that in case of Stream API, it will always be a pool approach where the subscriber pulls values from the publisher, while in this case it's kind of the opposite. Even though it might look to be confusing, in this case of flux we will have the subscriber always needing only to, and be attentive, only to request values, not to consume them. So subscriber requests values, and a subscriber can request 1 or more values. So I don't think I've shown you last time, but I can make my subscriber request for 2 values, 10 values, and that's the thing that we are calling back pressure, isn't it? It's something that we discussed in the previous lesson. The back pressure is the possibility the subscriber has to decide how many values they get from the publisher, which is something you don't have with the Streams API. So see, in the case of the Streams API, we have no back pressure. The consumer, the subscriber, call them whatever you want, will take values one by one and will consume them, and will use them somehow. While in terms of the reactive stack, the difference is that we have a bit multiple steps. First of all, the subscriber requests value. So there is no value sent from the publisher to the subscriber if there is no request. And that's something, again, if you are going to review the previous lesson, you will see that something we did. We started by not requesting anything, and you saw that the publisher doesn't provide anything. Because in the case of the reactive stack, the publisher is forced to only provide the subscriber what they requested. Otherwise, that would mean they don't respect back pressure. Because what back pressure is making sure that the subscriber only gets that amount of events that they can process. And the publisher cannot know which is exactly this number of events. So who knows what is the right number of events? Of course, the subscriber knows. The subscriber knows if they can or not serve more or less events. So it's their duty to decide how many to request. They can request them one by one. They can stop at some point. You can even programmatically do that request of the events. You can have a smart subscriber that requests events, then maybe pauses the request and then starts requesting again. It really depends on what you do there. So you can say that the reactor stack is much more intelligent in the end and much more complex than the simple stream API, which it's also kind of a pipeline approach for processing events, but it doesn't provide the way to implement back pressure, and it's always the subscriber just pulling events, while here the subscriber requests events and then the publisher provides, you can even say pushes, no? The requested events, and always only the requested events. So you see, in this case, being the exactly opposite, because the subscriber requested, but the publisher will be the one to push the events to the subscriber upon their request. So for those of you who asked me on LinkedIn or Twitter or even here on YouTube, I had several questions on which is the difference. I hope that now it's a lot more clear on this difference. So I'm going to say request here, and then I'm going to just let me complete the implementation to make sure. Now I have a very, very simple implementation of the subscriber, the same that we used last time, where when subscribing, the subscriber starts by requesting one value. You know that the publisher pushes the value. The value will be pushed from the publisher to the subscriber by calling the onNext method, and then after doing something with that value, like in my case printing it in the console, the the subscriber will request one more value, and that will basically happen up to the point when the publisher will have no more values. And again, if you remember from the previous episode, is the time when onComplete method is called. So I'm going to prove that, and then what I'm going to do is I'm going to start on our today's plan discussion, which is allowing me create a publisher for you. So one question while my app is starting, is it possible to use Flux for Spring application events? Is it possible to use Flux for Spring application events? I'm not sure if I understand the question. Is possible to use Flux with Spring application events? If that means creating a reactive app, then the answer is yes, and that's something that we've been working on starting with lesson 1. So maybe it's helpful if you review lesson 1, 2, 3, 4. I'm not sure, maybe they already answer your question, because for me Spring application events in terms of lifecycle events, I'm not sure. Maybe you want to be a bit more clear on what you mean Spring application events. If it's lifecycle events, then yeah, you can still do that. I'm not sure what would be the usefulness for that, but you can create a publisher out of anything, and that's what I'm going to show you. Of course, I'm not sure if I did already, but I'm going to show you that you can create a flux out of anything, because for the moment I know we only use the just method, maybe some create method, but I never shown you how to programmatically create a flux, and that's maybe where the question comes from. But before doing that, of course, I think it's again more important to understand about this, having this custom subscriber and custom publishers. How can you do something like that? So let's see you have publishers. We have publishers, and in the publisher, let's say we have here a class called demo publisher. So can I create my own publisher, like Flux is a publisher, Mono is a publisher? Can I simply create a custom publisher? Of course, the answer is yes. You will, again, and I'm going to say it for those who joined later, I don't think that you will need very often that in real world applications create a custom publisher. Usually having Mono and Flux is more than enough, but I feel it's very important you understand very well the structure behind the scenes. So that's why let's actually create the publisher ourselves. How do you create a publisher? Well, you extend, of course, the publisher interface, which from the last episode we remember it's the contract representing a publisher in a reactive in the reactive reactor applications. So it's only one method, fortunately, that you need to override. So the contract allows us to do whatever we want in terms of the implementations, obviously, because that's why it's only a contract and not an implementation. But it tells us that any publisher needs to have a subscribe method, which is, if you go back to what we did today, what we did last time also, it might look pretty obvious why, because, and remember, there is no complete pipeline we have without having a publisher and a subscriber. So you need at least a publisher and a subscriber. So you need a way in which the subscriber subscribes for the publisher, and that's why the contract in reactive streams is defined this way, because you obviously, from the philosophy of the entire philosophy of reactive applications, you need to have a way in which you can subscribe a subscriber to a publisher. So that's the subscriber, which you already know, and even today we've seen we took the subscriber and we implemented it, and that's what you need to override and make sure you have. So let me override the only needed method in this case, which will allow me provide a subscriber, and then you will see further, once I have a subscriber, what I need to do is give them a subscription. So you do remember that the steps were, and if I'm going to put some timelines again, they will become more clear now. So once you subscribe, first of all is that the subscriber subscribes. Oops. And that happens when you call the subscribe method. So here it is, call the subscribe. And that's something we now implement because you wanted to create a custom publisher, so you need to implement the subscriber. But what's important is that the subscriber, first thing the subscriber does is providing the the publisher does after the subscribe is providing the subscriber a subscription. So that's what we are going to do. So now you go back here, and when you get the subscriber, basically first thing that you expect is that you will have to call the onSubscribe method, and this way you provide them with a subscription. And subscription, fortunately, is not that a difficult contract, and we know it from previous lesson, is that it only has the request and the cancel methods. And the request method is maybe the most important. The cancel, of course, we know, and it's easy to get what it does. It cancels the subscription. The request, however, that's the action method. That's the most important, because that's what will give the subscriber the possibility to get more values. So what will we do in this case? We will create a subscription as well. So I will create the object demo subscription, and that will implement the subscription. And then of course I need at least to have the request and the cancel. And I'm not sure, maybe we could have used the subscription directly in the publisher. We will see if we complicate too much the things. But let's say that we use the demo subscription. Demo subscription that I created. And that's what you provide here to the subscriber. So now you literally have a publisher, and I'm going to my controller, and what I'm going to do is comment this out and redeclare the F1 as being my custom demo publisher, which if I leave it this way, it will definitely mean nothing, because, well, you can see it's actually a publisher that doesn't do anything. And then maybe your question would be, what if we really want it to do something? What can we do in that case? Well, let's just think that our demo publisher is based on a list, and let's say it will provide values from that list to any subscriber. So in that case, let me just say I have a list of integers, and let's just assume that we get this list using the constructor. So in this case, when I'm creating the publisher, that means I will have to provide this list. Okay, and now I have a demo publisher, which is a custom publisher based on a static list, in my case with some integer values. And the question is now, how do we implement the logic behind the scenes? How do we make sure this subscriber here, be it a custom one declared this way or just a simple subscriber, how will it get the values? Well, it's pretty simple, isn't it? Because we know now that the subscription will be the one to make the publisher and the subscriber communicate one with the other. So we know that once the subscriber subscribes, the onSubscriber method will be called, and that's what we did here. So we called the onSubscribe method and we provided the subscription. And now what we know is that the next thing that happens is that the subscriber, where is it, will always have to call at some point the request method on the subscription, and by the request method to tell us what they actually want. So in my case, the demo subscription here, it's basically where we will get the request. Now to make it maybe to make it easier, we can create a subscription that will be directly in this class here, so that we can use the list from the request directly. Otherwise, we need to create an observer pattern between those, and that will make the things a bit more difficult, a bit more complicated. So let's just say subscription new subscription. Okay, and then what you know here is that the request will be called telling us how many will we deliver. So now every time the request is called, what we want is to call the onNext method of the subscriber with the next element from the list. That definitely means we also need somehow, and usually in the subscription, to keep track of which is the last element that we have provided. So say last element. Let's say last element, and what we do provide here is list, and that's last, which is last requested element, actually last requested, just to be more clear. So a question, but I think that one is something that we will leave for later. But to very shortly answer, what is the link between using RxJS from the client side and Reactive Stream from the backend? There is basically no link. There are two technologies. One is JavaScript and the other one is Java. Both of them implement the same reactive basically philosophy. And whenever you use a reactive backend, of course, it's recommended that you use a reactive frontend, because otherwise you wouldn't have the benefit of consuming the event one by one. So what's the link between them? I would say, aside from the fact that they both represent reactive implementations, and that is recommended you use them together when you have and that's something we discussed in the previous lesson. When you have a reactive backend, it makes sense to have a reactive frontend. There is no other link between them that I can see to describe. So what I can say here is that, so you get the last requested element, and then when you call request first, let's say ++ here, and start from -1, and then at some point we will have to make sure that we call the complete method. No, let's say if the last requested element smaller than list size, then you can, it means you have one more element. Otherwise, and then otherwise you say subscriber on complete. So when you reached the end of the list, you don't have what to provide next. It means the string completed. So that, I think this is the minimum possible implementation. And if I didn't write anything wrong, that will simply provide from the publisher to the subscriber the elements one by one. So the idea is pretty simple. And in the end, I put my subscription here just to be easier to see the code in one place for you. But in a real world scenario, remember, never do something like this. A cleaner code will always decouple the objects. Okay, cool. So I just requested again from the endpoint, and I see the values here. So this is an example of the simplest custom publisher. I go back here, publishers. Let's take out the subscriber also, and then discuss them on the diagram. Okay, so that one implements subscriber, and I'm just going to take exactly what I had here and put them in the class so that we can write something like this. And you can see here that the demo publisher is our custom publisher based on the list. It creates an object of type publisher with that list as an attribute, to which I just subscribed the demo subscriber, which is, as you can see, of course, a custom subscriber. So we have custom publisher, custom subscriber. And now on the diagram, first thing that happens is the subscribe method. Inside the subscribe method, you can clearly see what happens with the subscriber. So somehow, line 19 here, the publisher will create a subscription object, and that subscription object is provided to the subscriber. So is the publisher giving a subscription to the subscriber. So the publisher gives a subscription to the subscriber. So what happens then is that we go to the subscriber and we see that when the onSubscribe method is called, the subscriber calls further the request method of the subscription. So on the diagram, we will say that the subscriber calls the onRequest method. That would be subscription on request, telling the publisher how many values the subscriber wants. Observe that in my case, this is a very dummy implementation of the publisher, because I don't consider the value. So this parameter here is the one that should tell the publisher, hey, I want exactly this number of values, which of course happens in case of a flux, but in my case here, it would have been too long and too complex to re-implement everything, including the back pressure. In a normal implementation, this is what allows you to implement the back pressure. In my case, I don't consider it. I always provide only one value. So in my case, you can see clearly that I always provide one value. I don't consider the value that is sent by the publisher. But remember that here, that value is the one where the subscriber tells the publisher exactly what they want. So that's, I want one. And then what the publisher does, if they still have values they can provide, they will call the onNext method on the subscriber. So they will say subscriber onNext and will provide them with that values. And then of course nothing happens anymore until the subscriber requests again, and then if there are still values, the publisher will call again the onNext, and again and again and again until the end of the stream, when no longer the publisher contains values. Like in my case here, the moment I stepped over the last index of the list, I will go on the else branch, and then instead of providing a value, because I don't have one more value, okay, and instead of providing a value to a subscriber, I call the onComplete method. So I hope that this makes clear now what happens behind the scenes in my, of course, not complete, not I say incomplete publisher implementation, because I don't implement back pressure and I don't implement the cancel, as you can see here. But even though it's pretty clear now, I hope what actually means and what back pressure is. So the subscriber and the publisher, the two actors in a reactive application, how they communicate one to the other, the difference between a stream, a normal stream, and the reactive, the fact that in a reactive application always the subscriber has to ask for values, and the subscriber has to ask for values, and it can ask for as many as they want, and it will be the publisher pushing the values to the subscriber after they are requested. So that's a very important difference between a normal stream and what a reactive implementation is, and that basically I hope demonstrated now with what we made here. Now let's go a bit back. So what else do we need to know about Flux? Okay, it's clear that Flux is a publisher, and now you somehow understand what's behind the scenes. So you do understand now, hopefully, what happens when we wrote something like this: subscribe, and you know here is the publisher and that will become the subscriber. But what exactly can we do to provide values here in a programmatic way? Because up to now, in the previous episodes and today, we either use the just method or we simply use different methods like the create here, like the from here, where we learned that you can have a stream, you can have any kind of collection, you can have an array, or even you can create a publisher from another publisher. But what we need very often in real world scenarios is to have a programmatic way to define a stream, a flux, a publisher. So how can you programmatically define a publisher? Because otherwise, using the just or the from methods, it looks like you always create a flux from something that's static, which will not be always very helpful. So let's say we want to create the values, to define the values programmatically. In that case, you will use the create method. So in the create method, you will provide a consumer, and what this consumer takes is what we call a sink. Well, you know, in a sink you can flush the water. Just imagine that in the sink here you just flush the events that you need to send through this flux. Basically, in the sink you will have methods such as next, complete, or error that will allow you to programmatically send values, like create your publisher, have whatever values you want to publish, whatever values you want it to generate, without needing to do what we did here, like create a custom publisher. And that's why I was telling you earlier that I doubt you will, in a real world application, ever need to create a custom publisher, what we did here. So that's why I didn't stress too much on implementing it properly, like from scratch to a definite perfect implementation, because you won't need that. I only used the demo publisher to help you understand better this diagram, to help you understand better the two actors and the communication between them. But in a real world application, even when you want to create something programmatically, you will still use flux most likely. So in my case here, for example, if I want to create a flux that generates 10 random unique identifiers, I can just say iterate 10 times through something. If I want it to be a string, then I need to make it a string, but the idea is the same. And next, and then say I want to create 10 identifiers. And of course, I need to say when something ends. So in this case, if this is a finite publisher, finite publisher, meaning it publishes a finite number of events, then at some point you need to have the complete button, the complete method called. And you might have also an error that you want to catch and signal from the publisher to the subscriber, and in that case you can do that through the sync using the error method. But in this case, for example, this is a programmatic implementation of a flux that I made to simply publish 10 random unique identifiers, universal unique identifiers. It simply works like any other flux, and it's just an example in the end. So that happens when I call the method. These are the 10 unique identifiers. But it shows you basically that you can programmatically do anything with a publisher. So you can simply make a publisher publish whatever event taken from wherever you want. So don't think of the publisher as something that is always fixed or starting from a collection of elements that already exists. This is something you see only in examples and demonstrations. You'll very likely not use the just method in a real world example, because it makes not a lot of sense to simply create a flux of some static values. But you will very often, when needing to create a flux of your own, you will need to create a programmatic implementation of the events, of the way the events are generated. And that's very easy to do using a sync. So you simply have this sync, you use the create method of the flux, and through the sync you call the next method to publish an event, you call the complete method to signal the completion event, or you call the error method to signal an error. And this way you can basically programmatically create a custom publisher publishing whatever events you want. Which don't need to be static anyhow. You can program it. So that's basically one of the things that I wanted to tell you. So we've seen a custom implementation, but we also saw a more realistic implementation for a custom publisher in a real world example. What else do we need to know? Well, of course, we need to know that on the pipeline, you might use several values on the publisher, which will transform what the subscriber gets. And not necessarily, maybe they will transform, maybe they will act on several events. And that's something I would like to continue with, which will most likely go into the next lesson, so not today. But one of the things that you can use, and that's the only one I want to discuss at the end of this lesson, is the log method. So this is the method you can use and you will use when learning about Flux, Mono, and Reactive in general to understand easily what happens behind the scenes. And that's what I use, what I usually use to explain the back pressure. So I want you to see the events here, and this log method help you see exactly the events in a nice way described between the publisher and the subscriber. So just by adding the log method here, when I will call the endpoint, you will no longer only see the values, which is what I printed from here, but what we are most interested in is the events that have to match exactly what you saw on my diagram. So first of all, the onSubscribe method has been called, because that's always what we learned that happens in the beginning. Always the subscriber subscribes to the publisher and gets back a subscription. So the subscriber subscribed and got back a subscription. And then the request method has been called. And one interesting thing here is that you can see that this way of providing a subscriber calls basically a request of an indefinite number, which means it simply says give me whatever you want. This request unbounded is equivalent to give me whatever you have. So the publisher here simply gave event by event everything it had up to the point where there were no longer values, and then it signaled the completion method. But that means that this kind of a subscriber that we created here using a consumer and the subscribe method doesn't use back pressure. Why? Because back pressure would have meant that the subscriber requests only something, gets some events, and then requests further some other events whenever it's needed. But no, in this case it's clear that the subscriber requested everything the publisher had, and then the publisher simply pushed to the subscriber everything. So I read that if you want to use reactive, you need to implement it on every layer, even on database, otherwise you will not benefit from the reactive padding. Can you explain why? Yes, that's what you read is correct. Well, it's very easy, isn't it? So in case you have multiple layers in the application, you have the controller and you have the service and then you have the repository. So it doesn't really make a lot of sense to have the service and the controller event-based implemented as reactive if the proxy, which is basically the one that connects to a database, is non-reactive. Because if this one is non-reactive, then at some point the service will wait for it. We do use this reactive paradigm a lot to avoid having our threads waiting for something. Actually, what we want to do is to have the threads starting to work on something else in case they are blocked by something. But if you have an application but the database you connect to has a non-reactive implementation, so you don't connect using, like we did in the first lesson, the R2DBC implementation, but you use the normal implementation, then this one will be blocked by this one. And then it doesn't make a lot of sense you have this one reactive. You can have it, of course, but since it will be anyway blocked by this one, you will have the same result basically as when the entire application is non-reactive. So yes, it makes sense what you read, that you either have everything reactive or have it non-reactive at all, because you will simply only over-engineer your application if you don't have everything reactive. Because if you have one part of the application that is non-reactive, you will end up with everything non-reactive, even though you implemented it with Flux and Mono, because they will be blocked by the non-reactive part. Same when you have including the front end. If you have a backend that is designed reactive but you don't consume it in a reactive way, and I advise you see the first and the second lesson here where I've shown you that if you don't put the events, you will basically have the client waiting and get even if you put the events, you will have the client requesting and waiting for everything up to the end. So if you don't have a client that is reactive but you have a backend that is reactive, it still doesn't make sense. You will still not benefit of a lot from it. So that's why what you read is basically correct, and it makes sense. So what I wanted to do is, as a last part of today's lesson, comment this out and come back to my reactive subscriber, to my subscriber using back pressure. New subscriber here. And what I'm going to do is basically the same thing I've been doing here. So I have my subscription, and I have my request, and I have my own next implementation. Okay. And then when I write, so take a look at the difference. We saw request and then a lot of nexts, and now it will be a bit different, which is request, next, request, next, request. So you see now it's much more clear that the subscriber can request only a small, in this case one number of events, and then the producer will only provide one event and will stop providing any event until it gets a new request, and then it again provides the event, and then it waits again, and the subscriber has to request. And this is exactly what happens in our case. Is precisely what we were expecting. After the subscription, the subscriber requests one event, the publisher pushes one event, and then waits for another request, and the subscriber requests again, and then it gets again another event, and so on and so forth, up to the point where it's complete. And of course you can implement, again what I was saying, you can implement to have two here. So say give me two, and then we can request two again if you want, which means that we will have to be sure to call the request only every 2 times. So that requires a bit of a more implementation from our side. Say you need an index, and you can do something like if I, so call it only once every 2 requests. But the idea is the same. So you will call it and then you will get every time 2 values. That's possible. That's basically back pressure. That's an idea of implementing back pressure. So you see the difference? When I requested 2 and every time 2 values, now I say I subscribe, please give me 2 values, and then the publisher tells me, okay, here are your 2 values, and then it waits again, and then I come back and say, please give me again 2 values. Okay, here are 2 values, and then please give me again 2 values. Okay, here are 2 values, and so on and so forth, up to the point where there are no longer values and the onComplete method will be signaled. So that's basically how it works. And then, can a publisher have many subscribers? Yes, it can have many subscribers. So take this F1 here, for example. You can implement, you can say subscribe and then you have as many subscribers as you want. For example, here. And this will actually work. So the same publisher can publish the same. It's not actually the same events, isn't it? Because you will basically have different. In my case, being random, they will be different events. But the idea is that you can have actually multiple subscribers. This is it. And that might be again something that creates confusion, because if we go back to the stream, you might remember that in case of a stream this is not possible. So if I'm going back and say again, you won't be able to say as for each. Two times. Because if you try to do that, you will get a very big exception. So if I'm copying this 2 times, sorry. If I'm copying this 2 times, the second one throws exception. Okay. So this one works, but this one doesn't work. Once you started the stream, you cannot reuse it. So that can also be treated as a difference, if you want, between the stream and the reactive, the stream API and the reactive stack. Okay, so let me prove you. If I'm calling it now, boom, big exception. First one worked. This is the first one. And then the second one told me stream has already been operated. So this line here doesn't work. Okay. But it works for the case of a flux. Cool. So I think this is it for today, guys. We got a lot into how a custom publisher can be implemented, and I think it's and hopefully it's more clear now, the relationship between a publisher and the subscriber. And we even discussed about the fact that you won't really create custom publisher in real world apps, and that's why I taught you how to use a sync, which is the way in which you programmatically can create a custom subscriber using Flux. So you don't need to rewrite Flux for that. You just need to tell the Flux how to produce the events, and the events are either providing a value or the completeness of the stream or an error. With that being said, you basically have now everything you need to create your whatever publishers you want. In case you need custom subscribers, you can now create your custom subscribers as well, even though in real world scenarios even that's not really the case, because going back to what we've been doing in the first 3 lessons, you know that the subscriber is attached automatically in the web application by the Spring Boot app. And what we are going to do next time is discuss a few more methods, important methods, like the log one, so like this one here, that can be part of the pipeline. So it's only being started today. I've shown you how to log the events, which is a very important thing, and it's part of what we wanted to do last time, and today describe the architecture and the relationship between the publisher and the subscriber. But what you will see is that the publisher Flux actually implements a lot of nice methods that allow you to combine the values, and using a functional approach, basically do whatever processing you need with them. And what I'm going to show you next time is the methods that I consider the most important, the most relevant to know, and of course provide you then with enough knowledge to be able to use the documentation for whatever other methods you might need in the future. You don't need to know all of them by heart. I think Flux has 50-60 methods there, maybe even more. You will see next time, and you don't need to know them by heart, but you need to know a few of them that are really important. And then of course you need to know how to use the documentation to get use of any of the others in case you need. So that will basically give you all the power you need to write the logic using Flux and Mono for reactive application. And then it will give us the possibility further to go to other subjects, such as how to secure our applications, and why not, of course, WebSockets and RSocket, which are some different concepts that we will discuss in later lessons. If everything was clear, hopefully, and we covered a lot of things today already, thank you very much for being here again, and hope to see you for the next lesson to discuss important methods of the publishers. Cheers and have an excellent time for study further.